Hello, welcome everyone. My name is Helena Laurent. I'm the head of a piece of work called The Future of Manufacturing and Production at the World Economic Forum. It's my pleasure today to moderate an issue briefing. It's about 30 minutes only with two fantastic leaders entitled, How Can We Fix Our Productivity Crisis? Now, this is all about the fact that we see and hear about the effects of new, incredible technologies all the time. We are in the fourth industrial revolution. Paul Polman from Unilever claimed that the speed of innovation has never been faster. Bill Gates observes that innovation is moving at a scarily fast pace. Eric Schmidt has talked about the age of abundance. The problem is we're not seeing that in the stats yet. The measured productivity growth has stagnated in some of our key economies. And so there are a lot of questions about why that is. One is the technology actually going to deliver us this productivity increase? I was reading something the other day that actually all of the social media, all of the distractions that we see have cumulatively an impact that's a reduction of 10 IQ points. You know, that's sort of equivalent to losing a night's sleep or double the impact of taking marijuana. So maybe we have false hopes. Maybe our measurement is not the appropriate way to see productivity right now. Maybe the fact is that some are getting more productive, others are not. But maybe it's just a timing issue. And so we have two leaders drawn from the World Economic Forum's network here today who are going to lead us through a little bit of thinking on this. To my right, we have a technology pioneer of the World Economic Forum. Rick Fulop is the CEO of Desktop Metal. It's a company based out of MIT that is driving forward 3D printing. Additive manufacturing. And he's going to tell us a little bit about that and what productivity impacts we might see there as an example, and how fast that is moving. Yes. On my left, we have Erik Brynjolfsson from MIT, of course, of second machine age fame, most recently Machine Platform Crowd, and many, many other studies on, from an economist's perspective, on how productivity will evolve. And we'll draw on both of their expertise here. So we will have time for questions from the audience, so please start getting your questions ready for us. I'm going to turn to Rick first. As somebody who has invested heart and soul into technologies, and in fact you're a serial entrepreneur, what makes you think that 3D printing is the thing that's going to drive us into a new productive era?
Yeah, I mean, I think we can categorize. I'm a mass production person, been doing hardware for a very long time. And you can categorize technologies that increase productivity in two groups. Some are kind of micro-level improvements in productivity, and those are, you could consider them incremental things that you need to do to stay competitive. But they are tweaks, 5% every year, 2%, 1%, and it's just optimization. And then you have every generation or so, you end up stumbling into a new technology that at first it seems like a toy, but eventually it turns into a major force of change. And you saw that with the internet, where the internet was available for maybe 20 years before it really left academia and left the military and started getting adopted by industry. And that drove a huge improvement in productivity through the 90s and the early 2000s in our global economy. And then we're now seeing probably the tail end of that phenomena. I would say IoT in manufacturing is, in the category of micro, not macro. You're tweaking things at that point. You've been collecting data for all the things that probably mattered in a Pareto chart, that 20% that is 80% of the cost. And then now people are starting to monitor the remaining 80%. But that only accounts for a smaller percentage of the cost. So I would say, coming from the additive manufacturing space, one of the things that I'm very excited is additive manufacturing has been maturing for 20 years, and for a long time it was only prototyping, it was not mass production. And now you have a number of companies and technologies that in the last 2 or 3 years have introduced a new set of processes to mass produce parts through additive. And that completely changes the game. For example, the company that we run is able to print metal parts 100 times faster than the previous generation technology, and it does it cheaper than casting and cheaper than machining. So for the first time, you can make parts for cars, consumer electronics, and other devices that are cheaper than the current process they had, but with the benefit of no tooling, there's no waste, and you can change your design almost every 6 months if you want, or every 3 months, because you're not stuck to a set of tooling equipment or an environment that you'd have to amortize over a long period of time. So I would just prefacing it with that, I think we're at the early stage of a huge new wave that lets you make parts differently than you made them ever before.
And you brought some show and tell.
Yeah. So this is a part for BMW that goes in a water pump in a vehicle. This is a part for an aerospace company, and what you see that's unique here in the back, I don't know if this is visible or not, but you see a lattice structure that's inside of that part that makes it very lightweight for the type of material that it is, and you couldn't make this part any other way. So this was the reason people started using additive in the first wave, but now they can use this design in mass production. And one of our machines makes 150 metric tons of parts a year. So this is not something you put in your house to make plastic tchotchkes. This is really something that you'd use in a mass production environment to make parts for products that go in everyday lives, products.
And by when, you mentioned in a meeting we had the other day that it's maybe 80 years before we see this truly in the world around us, or is that, what time frame do you see mass production?
80?
That's what
I say the arc is going to be
Okay.
as long as 80, because you think of $12 trillion worth of stuff that's made every year. That's a lot of machines to make product. But this is going to be a growth area. Just like semiconductors was a growth area for 30 years until it kind of matured as a business. We're at the big, it's a really exciting time. It's kind of like being in the computer industry in the 1970s, where it's, already a bunch of work has happened, but we have incredible pull from the Global 2000. So it's a great time to be in this space.
Okay, excellent. So we've got a very clear techno-optimist to my right.
Yeah.
And in fact, work that we've done recently with McKinsey, the Global Institute, talks about a potential $3.7 trillion worth of increase in the global economy if we can move to scale with this type of technology in production. Mm-hmm. Now, so I'd love to turn to you, Eric, with your sort of economist view and the broader picture, and recent work actually on AI as another example of technologies that could increase our productivity. What is the fix here? Is there a fix?
Well, first let me just put this in
Yeah.
context. I think that Rick is exactly right that we're in early stages of a real technological revolution. I think of the scale and scope of the first industrial revolution and the changes that we saw through society that did have an arc of up to 80 years to play through. And right now it's being driven by a new set of technologies. Additive manufacturing is a big one, and Rick's company's desktop printing is doing some amazing things there. But there are a few other ones, digital technologies that are connecting billions of brains together, these new platform-oriented companies we talk about in the book. And I think especially artificial intelligence in this area of machine learning that promises to do for our brains, augmenting them the way earlier generations augmented our muscles and the physical capabilities. But there's also a bit of a puzzle, and you alluded to that in your opening remarks, that despite these unquestionably wondrous technologies, and I could go on with a longer litany of specific successes, if you look at the productivity statistics, they've actually been not just disappointing, they've been slowing. So the productivity growth was in the early 2000s at the rate of about 2.5% in the United States. Now it's down closer to 1.5% or even 1.2%. Bounce this around a little bit. And that's true in most of the OECD countries. It's slowed down significantly, and in the developing countries as well. So there's a bit of a puzzle about what's going on. And you touched on some of the possible explanations. There is certainly some mismeasurement. But ultimately, I think that we should take some lessons from history. And these earlier industrial revolutions, they had also amazing technologies. Take electricity. But it took a while for people to figure out how to really use them, to invent the new business processes, the new organizational models, the new business models, to incorporate the kind of technology that Rick was just showing us to change their supply chains to take full advantage of it. And until they make those kinds of organizational and business changes, you don't get the full benefit. In fact, our research shows that initially, as you make the investments and wait to harvest them, you could initially have a productivity drop. And then ultimately you get that paid back with interest. So to get to your specific question, what sort of things can we do? We need to invest in human capital and education. We need to speed the process of learning and diffusing these new techniques. We need even more entrepreneurs like Rick who are developing new ways of doing things as the old ones get automated and removed. And government needs to step in with things like investments in infrastructure and R&D. If we put together a package of those things, I think we can massively compress the timeline till we get those productivity benefits that I'm sure are in the pipeline, but we're not seeing them yet.
Okay, and time frame, would you put a prediction on when we might see the fourth industrial revolution take hold?
Well, parts of it are already taking hold in different places. So there are certainly areas where we're seeing some payoffs, and we did have a little bit of a productivity uptick last time. I don't want to go quarter by quarter, but I think that there will be portions of it that will play out in the next few years. Others, say self-driving cars, that could take a decade or more. And then there are some that are even more long-term about ultimate totally rethinking of, say, healthcare and the way we deal with our human bodies. So there'll be a wave of changes that continue to play out. But I think some of them are already beginning to happen.
It happens sector by sector. When you think of how additives change some sectors, the adoption curve in hearing aids, which are mostly additively manufactured today, happen over a 3-year period, almost from zero to, because it was less expensive to do them that way. In aligners for teeth, the same thing. It happened in less than 5 years. So it could, when a sector tips, it's very fast. And, we usually...
A lot's going to depend on the interdependencies. In those areas, it's a relatively self-contained thing, and that helps speed up.
That's right.
In other things, like, say, self-driving cars, you have to do some more fundamental rethinking of things like rules of the road, insurance, liability, and so that can be a more complex ecosystem that has to evolve. And that's why you're going to have different time frames for different industries.
Yeah.
I could say, in Dr. Schwab's book, he mentions when will additive really be a done deal, and he talks about it when 80% of a car is made through additive manufacturing. And just from our own business, even being at the early stages of it, we work with major car makers, and they have significant effort in trying to infuse additive throughout the vehicle supply chain, because it gives them so many benefits from design flexibility, inventory, tooling cost, no tooling, ability to modify and optimize
one of the really
designs.
interesting things about what you're doing is that it takes away a lot of the constraints about the kinds of designs people can do. Before, you had to make sure that it was manufacturable in the old way.
Yeah.
But with additive manufacturing, you can be so much more creative, and it opens up a new space of capabilities and,
Exactly.
And trade-offs.
So let's pick up on some of the sort of the barriers. So we did, in the work we're doing on manufacturing and production, if you look at the drivers that will really help a country or an economy be ready for the future of production, it is technological diffusion, it's human capital readiness, it's a sort of institutional framework. So let's break those down a little bit and see where you think, what are the next steps that we could be taking now so that we move further and faster. So to Rick, how are you seeing, talk to us a little bit about the readiness for larger companies maybe to talk to a technology pioneer such as yourself? How do you see entrepreneurship burgeoning?
Only when there's real technology disruption do large companies talk to smaller companies. Our company's raised, $250 million. So we're not the traditional startup, but that's a lot of money.
Not bad.
And for startups, but even despite that, large companies would rather buy from a large company or an existing supplier. But they work with companies like us or with leaders in the world of autonomous driving or IoT, some of these other new technologies. They work with startups because they're the ones who have the leading edge in terms of technology. So that, once that technology is fully diffused and is available by large companies, they'd rather continue to work with their existing supply chain, make things easier. So it's, I think when we look back on this fourth industrial revolution, like Eric said, it's probably going to be a 50-year period of growth. It's an S-curve at the end of the day. And we're at the beginning part of that S-curve. When we look back and we think, what really changed? And it's going to be the way that we make stuff. If you look back at the previous industrial revolution, it was about the ability to get economies of scale making a product, whether that was, essentially that the enabling technology wasn't just the steam engine, but was really tooling. The ability to be able to produce something cost effectively in a given location. And that set up global trade the way that it's currently set up today and led to tariffs and all of that. If you think of the world, if you take a step back and look at shipping, the way that, or in trade, we send three things around. We send raw materials, we send parts, and then we send fully assembled products. What's going to change in this revolution is we're not going to send parts around. We're just going to send raw materials and finished products. You're going to assemble locally next to your customer for that market, for the taste of the consumer. And there's going to be a lot more interesting work because the work is not, the machines are going to make the parts, but humans are going to be liberated to work on the systems integration at the end of the process. And that's a more meaningful and interesting activity. It's kind of like what happened in programming where you had to do assembly and then you went higher level to a more interesting thing, which was C++, and then today you have Ruby on Rails or modern frameworks where you just have to tell a computer, do this, and then all the programming happens behind the monitor. The computer does a lot of it for you, so it makes it much easier. And I think product design is going to evolve that way.
So Eric, you said yesterday in a meeting, technology is a great catalyst, but ultimately it will take entrepreneur activity to change the way we produce. How would you scale up the type of thing that Rick is doing here and the jobs that will be created around design, around the services aligned with that?
So there's a cluster of things that we need to do as a society and as individuals. And I think Rick really touched on, described very well some of the changes in mindset that need to happen. There's going to be a lot less routine, rote, assembling of stuff, following instructions, memorizing facts. There's going to be a lot more need for creativity, entrepreneurship, design, figuring out what is the problem that needs to be solved, understanding customer needs, figuring out what are the capabilities we have, how to put them together, designing new products. And so certainly we need a bigger investment in the STEM fields, science, technology, engineering, and mathematics. But I would go beyond that and emphasize arts and design as well. And so it's been said we need to move from STEM to STEAM, adding the A into the group. And I think that the people who will thrive, particularly in this new era, as these technologies automate the basic routine parts of work, are the people who combine that kind of creativity, the artistic creativity even, with being able to synthesize the needs and problems that the world and the customers have with some technical chops that allow them to put it together. It's a rare combination today, but it's something that I think we should be investing more in teaching our kids, and actually lifelong. There's people at all ages that can learn those. So probably, if I were to lay out a roadmap, that would be the first item, is reinventing our educational and training system in that kind of a direction. Now, there are other things we can do to boost entrepreneurship, because we need more entrepreneurs as the old models get automated and we lose jobs in those areas as robots take them over. That should be good news, because that means we're getting stuff more cheaply, more efficiently than before, and it frees up people to solve all the other problems we have. And one thing I really want to emphasize is that there's no shortage of problems to be solved in the world. There's no shortage of work to be done. We are not entering a world without work. And there's plenty of things that only humans can do, like that list I just described of creativity and art. And so as we free up people from some of the mundane tasks, we should unleash their creativity to really attack the other problems that we face in healthcare, in the environment, in taking care of kids, in education, just a litany of opportunities. And that transition requires entrepreneurs who can reimagine ways of combining technology, capital, labor, and human ingenuity to solve problems.
Yeah. So it's about not just training ourselves, but also seeing the opportunity out there that this is these technologies are unlocking.
Pablo Picasso, when he saw some of the early computers, he said, well, I'm not impressed. All they do is give you answers. And of course, what he thought was really interesting was asking the right questions. And I think that's even more true today. And the people who can ask the right questions, they'll be the ones that drive progress forward.
That's awesome.
Excellent. So I think that's a great note to move and see if we have any questions in the audience. Would anybody like to ask a question?
Ask the right question.
Yeah, exactly. Gentleman here.
Yeah, I have two questions. First question.
Could you share who you are and where you're from?
Yeah, so
and welcome.
Isa Al-Saleh from Agility, a global logistics company. So I have a question here and a question here in terms of the technology themes that you were talking about. In these periods of big transformation and disruption, what's best for companies to be a first adopter, early adopter, or be more of an experimenting, go through experimentation as opposed to early?
You always want to be able to, you have to try things, and you have to be able to fail fast, but not probably try to avoid failing big. In that way, you're always learning, and that when it feels right, then you can expand. I mean, I think in the world of shipping, it's not like you're going to have less shipping. You're just going to ship either more finished goods or more raw material around in less parts. But I would say, the reason this is inevitable. There's three core technology drivers that are really going to change the way people make parts. The first one is something called generative design, which is a term most people haven't heard yet, but it's coming. And that's a process of design where you tell the computer in your CAD is the software you use to do mechanical design. You tell a computer the higher level things that the part that you're designing needs to do. You say it needs to connect from here to here, it needs to avoid these keep-out regions, and these are the forces that the part is subjected to. And then the computer does the design for you, and the software that's being developed today actually does an amazing job and comes up with shapes that you would never do as a human. It looks, you do this sort of bionic design, and that is a trend that's getting adopted at a good pace, and it's only growing. If you look at the CAD announcements for this year from the major CAD suppliers, every single one of them is talking about generative design. Last year, maybe 10%. So it is a brand new trend, and that gives you lighter weight parts. The second reason why people are going to do this technically is something called reductive decontenting. Reductive decontenting is a circular benefit that you get when you lightweight a part. So now you lightweighted the part because of generative. You get usually 30% weight savings. Now think about it. In the world that we've optimized the existing processes like casting and machining down to like the asymptote. You're not really going to get much. Now you have a new process to design that gives you unlimited flexibility in the way you make your part. So you have a whole new wave of optimization. So now you get, this wave gives you lighter weight parts. With 30% lighter parts, you can now start doing reductive decontenting. If a whole assembly of parts is 30% lighter, then the other things that interact with it can be lighter. For example, brakes in a car are going to be smaller because the other parts are lighter weight. That's an example. The third reason that drives this is consolidation of assemblies. Consolidation of assemblies allows you to print a single part, multiple parts as a single part. And that has huge impacts in your supply chain. GE did a turboprop engine where they took 855 parts into 15 by doing consolidation of assemblies. There's no fasteners. Everything is printed as a single unit. And the reason it was 855 parts before is because the way it came together. And then you needed to have supply chain people for 855 parts, inventory for 855 parts. Here you have zero tooling, zero waste, and you can, so these are the things that, this is inevitable. It's going to happen. So this is.
Yes.
The question would be, I mean, your question was around experiment. Do we experiment or do we go into this? We're into sort of pilot, one of the things we've noticed is a lot of companies are in pilot purgatory. There are too many pilots. So maybe Eric.
Yeah, actually, I did some research on this. So we had are we?
5 minutes. Keep going.
Okay. So I did some research on this and working with Christina McElhern, we looked at companies who were taking a more data-driven experimental process, a little bit like what Rick was just describing. We found that they were about 4 to 5% more productive and more likely to survive and thrive than the companies that stayed with a more traditional sort of planning and reacting mode. So there's increasing evidence that this approach of testing ideas, getting data back, learning very quickly, scaling up the ones that work is not just anecdotally successful, but quantitatively there's evidence to support it.
Does that answer your question? Yeah, excellent. And there's a question, gentleman behind you.
Hello, thank you. It's Hussein Kasai here. I'm also a tech pioneer from Onfido. And it's mostly for Eric. I've read your book and I am a fan. My question is around the productivity crisis in particular. Mm-hmm. How can the low-skilled use technology for their productivity to increase? Because
how can
the low-skilled workers
yeah, okay.
use technology for their productivity to increase? And this is in the context of increasingly the permanently unemployed. Mm-hmm. And yes. Naturally, a lot of the technologies that are discussed are pretty much for the higher skilled. And as increasing returns to capital, I guess, continues, there is going to be increasing inequality. Yeah. So the question is, what technologies or examples are there where the productivity of the low skilled?
That's a great question. I think this is the great challenge for our society right now. The only part I'm concerned about your question is there's going to be. There's no inevitable future. It's a choice of what kind of future we have. And we can change the direction of future so that we don't have that increasing inequality. We have had it the past 20 years, but I want to stress the future is not predetermined and it's not at all inevitable we'll go that way. One of the ways that, 3 ways that we can make it less likely that we have that less fortunate outcome is, number one, I'll come back to people who are low skill now. They don't have to be low skill all the time. So the first thing I just hit over and over is much more investment in human capital, retraining, giving people different sets of skills. And they don't necessarily have to be, going to 10 years of graduate school or anything. There are many types of skills that involve emotional intelligence, connecting to people, caring for people, where people can use some of their own innate strengths to do that. The second thing is that there are a set of technologies like augmented reality that are making it possible for technicians, nurses, others to do higher level types of tasks because the augmented reality helps guide them through the more difficult parts and it creates an enormous upskilling potential. You don't have to memorize lots of diagrams and facts when the machine can help guide you through those things. So by having a human-machine symbiosis, you can have people who previously were doing low-skill work doing much more high-skill work. And then last but not least, I think there's reinvention of the nature of work itself through going back to entrepreneurship, that if you combine tasks in different ways, you can leverage some of the skills people already have to redeploy them to create value in other sorts of ways. And I've seen lots of companies doing that. All 3 of those possibilities and options will lead us to a future where we don't have increased inequality. And the last thing I'd want is for us to take that for granted because people in this room and people watching here have the potential to change that direction of history.
Question in the front here.
Hi, my name is Amesh Kimji. I'm from Oman. I work in a lot of developing countries. Developing countries have leapfrog technologies in the past, yes. But it's been digital and telecommunications and so on. And how are the developing countries supposed to leapfrog into your new technology of whether it's 3D printing or artificial intelligence without going through the previous cycle of from A to Z? You can just go straight to.
I can make an analogy. So it has to do with the fact that digital technologies tend to be less expensive and more democratizing than analog technologies. So the equipment to make parts like this through in really high volume through an analog process would be the tooling required and the expense to set up, it's big CapEx, big capital equipment, if you're going to make millions of these. If you have a digital printing press all of a sudden and you can make any shape, that CapEx tends to be less expensive. And so it's a disruptive technology, and by not having an incumbent cost basis that you have to live with, that's already depreciated, and that's what you're bidding off of, you have a new advantage. Probably not as much initially, because it's new technology, but over time, all of these get to higher volumes, and the cost comes down, and then it's very affordable for developing countries. So I really believe that IoT, AR, the additive manufacturing technology that we're introducing for mass production is going to be very affordable to developing countries.
So let me be brief.
Any examples as well that you've seen that are particularly good?
So let me be brief. I think that your question had in it the seeds of the answer, and you do have to leapfrog. If you try to go through that whole sequence, you'll be so far behind. And what's more, the core of that sequence is being completely eviscerated by these new technologies. The traditional path for these countries of having low-cost labor, mass production, large quantities of workers is no longer going to work. And they're really in the bullseye of the robotic revolution, many of these other revolutions. So the only option is really to find a way to leapfrog. Like in China, you look at just one small example, mobile payments. There are about 50 times as many mobile payments using phones in China as there are in the United States, a technology leader, because they have just leapfrogged a lot of the other payment systems. And that has created an infrastructure for a huge ecosystem of what they call O2O, online to offline businesses. People, you can use your phone to call somebody to cook a meal, walk your dog, wash your car, drive you somewhere. And this entrepreneurial ecosystem is based on a leapfrogging set of technologies that didn't go through that sequence. Yes, yeah, and so that, but that O2O means online to offline. So it's got the whole offline component that has been catalyzed by a telecom technology.
Excellent. So I think we're being asked to draw to a close. We have a techno-optimist set of discussion leaders here. It's a timing issue. Having said that, there's no inevitable future. We do need to work on three things: diffusing those technologies so that we see them spread fast for inclusive growth, human capital, retraining, rethinking, and an institutional framework that helps us with that so that we're building together and we can fix productivity. Thank you so much to Eric and Rick. Really enjoyed the conversation. Thank you for the audience.
Thank you.